A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, today's prompt from Daniel is about the survival of LTO tape. And I have to say, there is something deeply satisfying about the fact that in 2026, the backbone of the internet is basically a very sophisticated cassette tape.
It is the ultimate survivor, Corn. My name is Herman Poppleberry, and I have been waiting for us to do a deep dive into magnetic media for a long time. People think the cloud is this ethereal floating mist of data, but if you actually pull back the curtain at a Google or an Amazon data center, you are going to find millions of physical tapes sitting in robotic libraries. By the way, today's episode is powered by Google Gemini 3 Flash, which is actually quite fitting considering how much data these models consume and the massive archival requirements they create.
It's funny you mention the curtain, because I always pictured the cloud as just endless rows of blinking hard drives. But you're telling me it's more like a giant automated version of my 80s Walkman collection.
In principle, yes. Linear Tape Open, or LTO, is the standard that won the tape wars. It was started back in the late 90s by HP, IBM, and Seagate to create an open format that wasn't tied to a single vendor. And here we are, decades later, and LTO-9 is the current heavyweight champion. We are talking about 18 terabytes of native capacity on a single cartridge, or up to 45 terabytes if you're using compression.
45 terabytes on a little plastic square. I remember when fitting a few songs on a floppy disk felt like sorcery. But help me understand the why here, Herman. We have NVMe drives now that are blisteringly fast. We have massive hard drive arrays. Why are the biggest tech companies on Earth still buying millions of miles of magnetic tape? Is it just because they're cheap? Or is there a technical aha moment I'm missing?
It's a combination of three things: physics, economics, and security. Let's start with the physics of bit rot. If you leave a hard drive on a shelf for 10 years, there is a very high probability that the magnetic bits will eventually flip or the lubricant in the spindle will seize up. A hard drive is a mechanical device with parts moving at thousands of revolutions per minute. Tape, on the other hand, is inert when it's not being read. An LTO cartridge has an archival life of 30 years. You can drop it in a climate-controlled vault, and 3 decades later, those bits are still exactly where you left them.
30 years is an eternity in tech. I can barely get a charging cable to last 30 days. So the durability is the selling point for the forever data. But surely the speed is a nightmare. If I need a file and it's buried in the middle of a 500-meter spool of tape, I'm going to be waiting a while.
That is the trade-off. It's the ultimate high-latency, high-bandwidth system. You don't use tape for your active database or your operating system. You use it for what we call cold storage. If you're a bank and you need to keep transaction logs for 7 years for regulatory reasons, or if you're a movie studio like Disney or Warner Brothers and you have petabytes of 8K raw footage that you might not need for a decade, tape is the only thing that makes sense.
But how does that actually work in practice for someone like Disney? If a director says, I need that one B-roll shot from 10 years ago, does someone have to go into a dark warehouse with a flashlight?
It's actually much cooler than that. It's all automated. They use these massive robotic libraries. Think of a room-sized vending machine. When the request comes in, a robotic arm zips along a rail, identifies the specific barcode on the LTO cartridge, pulls it from the slot, and shoves it into a drive. It takes maybe 60 to 90 seconds. It's slow compared to the milliseconds of a hard drive, but compared to a human walking through a warehouse, it's lightning fast. And while the seek time is slow, the actual transfer speeds are surprisingly fast. LTO-9 can hit 400 megabytes per second. That's faster than most consumer hard drives once the data starts flowing.
Okay, so it's fast once it gets going, but it's the getting going that takes time. I like the idea of a robot arm being the librarian of our digital history. It feels very sci-fi for a technology that basically involves rust on a plastic ribbon. You mentioned economics too. Is the price gap between a hard drive and a tape really that massive when you're operating at the scale of someone like Amazon Web Services?
It is staggering when you look at the total cost of ownership, or TCO. With a hard drive, you aren't just paying for the drive. You are paying for the electricity to keep it spinning 24/7. You are paying for the massive air conditioning units to keep those spinning disks from melting. You are paying for the rack space. A tape sits on a shelf and uses 0 watts. 0. It only consumes power when it's inside a drive being read or written to.
I never thought about the power consumption of just sitting there. A hard drive is like a car idling in the driveway forever, whereas a tape is a car that's parked in the garage with the engine off.
And the idling cost of a data center is the silent killer of budgets. Estimates suggest that for long-term archival, tape is about 80% cheaper than disk-based systems over a 10-year period. When you're Google and you're storing exabytes of YouTube videos that nobody has watched since 2012, think of all those Harlem Shake videos. That 80% savings adds up to hundreds of millions of dollars. If you tried to store all that on spinning disks, the electricity bill alone would be a national crisis.
I can see the bean counters salivating over that. It's slow, but it's free to keep. It's basically the digital equivalent of a storage unit in the middle of nowhere. But what about the security aspect you mentioned? In an era where ransomware is the monster under every IT manager's bed, does tape give you an edge?
This is actually one of its most modern advantages. It's called the air gap. If a hacker gets into your network, they can encrypt every drive that is mounted and spinning. They can wipe your backups if those backups are hot and connected to the server. But a hacker cannot reach across the room, physically manifest a ghost hand, and pull a tape out of a library. Once that tape is ejected and sitting in a slot, it is physically disconnected from the world. It is the ultimate defense against a total catastrophic wipe. You have a physical copy of your data that is immune to software-based attacks.
The ghost hand defense. I like it. It's the one time where being offline is actually a feature rather than a bug. I imagine there's a bit of a security through obscurity element too. Most 18-year-old hackers probably wouldn't even know how to interface with an LTO9 drive if they found one.
Precisely. Well, I shouldn't say precisely, but you've hit on a major point. The complexity of managing a tape library keeps it in the realm of the pros. But it's not just about the old stuff. Daniel's prompt asked if the standard is still evolving, and the answer is a resounding yes. The LTO consortium has a roadmap that goes all the way to LTO 14. We are looking at a future where a single cartridge could hold over a petabyte of compressed data. That is mind-boggling.
A petabyte on one tape? Herman, you're going to have to explain the materials science there. How do you keep packing more data onto the same physical surface area? Are they just making the tape longer, or is the rust getting smaller?
It's the rust getting smaller, and more specifically, how they orient the particles. They moved from metal particle technology to barium ferrite, and now they're looking at strontium ferrite. These particles are incredibly tiny. To give you an idea of the scale, we are talking about particles so small that you could fit tens of thousands of them across the width of a human hair.
Wait, if the particles are that small, how does the needle even find them? Isn't the tape wobbling as it spins?
That is the aha moment of tape engineering. They use something called servo tracks. These are pre-recorded timing marks that the head follows with extreme precision. The head actually moves up and down hundreds of times a second to compensate for any microscopic wobble in the tape. They've developed heads that can write tracks that are only a few hundred nanometers wide. If you laid the tracks of a single LTO9 tape end to end, they would stretch for over 80 miles. The precision required to keep that tape aligned with the head while it's flying through the drive at high speeds, about 5 to 10 meters per second, is one of the greatest engineering feats that nobody ever talks about. It's like trying to fly a jet through a tunnel with only an inch of clearance on either side.
It's funny how we obsess over the latest iPhone chip or a new GPU, but the precision tape aligner is the unsung hero of the digital age. It's like being the world's best at threading a needle while riding a roller coaster.
That's a great way to put it. And the ecosystem is surprisingly robust, even though there are only a couple of companies actually making the media now, Fujifilm and Sony. They had a massive legal battle a few years ago over patents for LTO-8, which actually caused a global shortage for a while. It showed just how fragile the supply chain is for this old tech. For a year or so, companies couldn't get the latest tapes, and it sent the archival world into a bit of a panic.
Wait, so the entire world's backup plan rests on two companies in Japan, not suing each other into oblivion. That feels like a single point of failure that would make any risk manager sweat. How did they resolve that? Did the tech industry just knock their heads together?
Pretty much. The market demand was so high that it became a mutually assured destruction scenario. They eventually settled, which is why LTO-9 exists today, but it highlighted the fact that while the standard is open, the manufacturing is incredibly specialized. You can't just start a tape factory in your garage. The clean room requirements and the chemical engineering involved in coating that plastic film with magnetic particles are incredibly high barriers to entry. You need massive, specialized factories that cost billions to build.
So, we have this tech that's cheap, durable, and secure. But Daniel asked who is actually using it besides the obvious suspects like Google. Are we talking about banks, hospitals, government agencies?
Everyone. If you've ever had an MRI, those massive image files are likely moved to tape after a few months. If you've watched a movie on Netflix, the original high-resolution master is on a tape in a vault somewhere. NASA uses it for satellite data. The Large Hadron Collider at CERN generates so much data, about a petabyte per day during experiments, that they have to use automated tape libraries to store the results. It's the only way to handle the sheer volume. In fact, cloud providers like Microsoft Azure have archive tiers where you pay a fraction of a cent per gigabyte. When you click Archive, they aren't just moving your file to a different folder, they are literally writing it to a tape and putting it in a rack.
I've always wondered about those cold storage tiers. I used to think it was just a slow hard drive, but knowing there's a physical tape involved makes the wait 12 hours for retrieval part make much more sense. It's not just slow software. A physical robot has to go find your data. But doesn't that make people nervous? What if the robot breaks?
These libraries are built with massive redundancy. They have multiple arms, multiple drives, and the tapes themselves are stored in passive slots. If the robot breaks, a human can actually walk in there and grab the tape manually. It's the ultimate break glass in case of emergency scenario. And that brings us to the cloud versus tape debate, which is actually a bit of a false dichotomy. The cloud is built on tape. But for a lot of medium-sized businesses, the question is whether they should own their own tape drive or just pay Amazon to do it. Owning a tape library is like owning a boat. It's great when it works, but it requires maintenance. You have to worry about drive cleaning, firmware updates, and the generational leap problem.
The generational leap. Let me guess. LTO-9 can't read my old tapes from 2004.
Well, not exactly, but close. LTO has a 1 generation back, rule for writing, and a 2 generations back, rule for reading. So, an LTO-9 drive can read LTO-8 tapes, but it can't read LTO-6. This creates a massive migration headache. Every 10 years or so, big organizations have to play this giant game of musical chairs where they move all their data from old tapes to new tapes before the old drives become museum pieces.
That sounds like a nightmare. It's the digital equivalent of having to rewrite all your books every time a new type of paper is invented. Surely there's a better way? Or is the migration just a cost of doing business?
It's a cost of doing business, but it's also an opportunity to verify the data. When you migrate, you're essentially doing a health check on every single bit. It ensures that your forever data hasn't actually started to decay. But there is a newer technology called LTFS, the Linear Tape File System. It makes the tape look like a giant USB drive to your computer. You can drag and drop files just like you would with a hard drive. It was a game changer because it meant you didn't need specialized, expensive backup software to see what was on a tape. It made the format much more accessible to smaller shops like post-production houses and boutique data firms.
I'm trying to imagine dragging a 4 terabyte file onto a USB drive and hearing the whirring of a tape reel. It's a hilarious mental image, but it sounds like LTO has successfully modernized itself. It's not just a relic, it's a high-tech tool that's been adapted for the 21st century.
It really has. And what's interesting is how it connects to the broader digital dark age concern. We've talked about this before, not on air, but in our own research. The idea that our current era might be a blank spot in history because all our photos and documents are on proprietary cloud platforms or fragile SSDs. LTO is one of the few things standing between us and a total loss of our digital heritage. If the power grid went down for a year, those tapes would still be there. You'd just need a way to spin them.
That's a sobering thought. We're building this massive tower of digital information on a foundation of magnetic tape. It's fragile in one sense. Magnets heat, physical damage, but robust in another. It's weirdly poetic. The most advanced civilization in history is essentially writing its story on strips of plastic coated in metal dust. Is there any risk of the tape itself physically degrading if it's not spun for, say, 20 years?
There is a risk of stiction, where the layers of tape kind of fuse together if the humidity isn't controlled. But that's why these vaults are so high-tech. They are kept at a constant temperature and humidity. Some people even suggest retensioning the tapes every few years, which just means fast-forwarding and rewinding them to keep the physical tension uniform. It's like taking a classic car out for a drive just to keep the gaskets from drying out.
So even the digital archives need a little exercise. I love that. And the unlikely survival part of Daniel's prompt is the most interesting bit. 10 years ago, everyone was predicting the death of tape. Disk is king, they said. The cloud will kill everything. But the sheer volume of data we're generating, especially with AI, has made tape more relevant than ever. Training a model like Gemini requires vast amounts of data, and once that model is trained, you don't just throw away the training set. You archive it, because you might need to retrain or audit it later. Tape is the only way to store that much data without going bankrupt.
And it's a very deep niche. Think about the energy efficiency. We are constantly talking about the carbon footprint of data centers. Moving archives to tape is one of the single biggest things a company can do to lower their energy consumption. A spinning disk array for a petabyte of data might draw several kilowatts of power 24/7. A tape library with the same capacity draws a few hundred watts when it's active and almost nothing when it's idle. It is the green choice for the data-heavy future.
I can see the marketing now. LTO tape, the eco-friendly way to store your cat videos. But seriously, if it's that much better for the environment and the bottom line, it's not going anywhere. I'm curious though, is there any competitor on the horizon? Is there some glass storage or DNA storage that's going to finally kill the tape reel?
There are experiments with Project Silica at Microsoft where they use lasers to encode data in blocks of quartz glass. That could theoretically last for thousands of years. And DNA storage is a fascinating field where we encode binary into the A, C, C, G, and T of synthetic DNA. You could store all the world's data in a couple of shoeboxes if you use DNA, but those are still in the lab. They aren't ready for prime time. For the next 20 years at least, magnetic tape is the only game in town for high-density, low-cost, long-term storage.
DNA storage sounds like something out of Jurassic Park. We've encoded the entire Library of Congress into this frog. I think I'll stick with the magnetic tape for now. It feels a bit more mechanical, a bit more understandable.
There's a certain honesty to it. You can see the spool, you can hear the motor. It's a physical manifestation of memory. And as we move into LTO 10 and beyond, the capacities are going to reach levels where a single tape could hold the entire life's work of a small company. We are talking about 36 terabytes native, 90 terabytes compressed. It's a staggering amount of information in the palm of your hand.
Well, I, for one, am glad the robots have something to do. Looking after our tapes seems like a noble profession for a mechanical arm. It's been a fascinating dive, Herman. I'll never look at a storage full notification on my phone the same way again. I'll just think about a robot in a dark room somewhere in Oregon frantically trying to find a spot for my blurry photos.
And it's probably an LTO9 tape doing the heavy lifting. This really is one of those invisible technologies that makes the modern world possible. Most people will never see a tape drive in their entire lives, yet their entire digital life depends on them. It's the ultimate legacy, technology that refuses to become a legacy.
It's the ultimate out-of-sight, out-of-mind tech. I think we've covered the how and the why pretty thoroughly. Any final thoughts on the future of the spool?
Just that we should appreciate the engineering. We live in a world of disposable tech, but LTO is built for the long haul. It's a reminder that sometimes the best way forward is to keep refining a proven idea rather than chasing the next shiny object. It's the tortoise in a world of hares, and we all know who wins that race in the end.
A lesson for us all, really. Don't throw out your tapes just yet. Thanks for the deep dive, Herman. This has been My Weird Prompts. Big thanks to our producer, Hilbert Flumingtop, for keeping the reels turning behind the scenes.
And a huge thanks to Modal for providing the GPU credits that power our show's generation. We couldn't do this without that serverless horsepower. It's what keeps our hot storage running while the tapes handle the rest.
If you enjoyed this look into the rust on plastic that runs the world, consider leaving us a review on Apple Podcasts or wherever you're listening. It really helps other curious minds find the show.
We'll be back next time with whatever weirdness Daniel sends our way. Until then, keep your bits dry and your magnets far away from your archives.
Goodbye, everyone.
See ya.
This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our